Here's a quick overview and example for dimensions and tolerances. So, first one, make sure that all dimensions are unique. Do not repeat dimensions across several different faces. We're always dimensioning with align multiviews, so this is usually pretty straightforward. You want to dimension the most descriptive view, so I wouldn't want to dimension this dimension from here to here. Rather, I will show that on the face where you can actually see what that feature is, what that cut is. Dimension between the views. I wouldn't put this 80 length over here. Otherwise, it's not clear to someone that it also applies to the top view, right? Omit one intermediate dimension. I do not need to say that this dimension from here to here is 30, because a reasonably discerning person would be able to figure that out just by looking at it. Finally, smaller dimensions nested inside of larger ones. This is also for clarity. These lines are called extension lines, and they actually go to the feature itself. I never want to see an extension line going through one of these actual dimension lines. Dimension only to visible object lines, not to the hidden ones. I am not going to show this width from hidden line to hidden line. That's not very useful, even if it is describing that. Again, it needs to be the most descriptive. Avoid dimensioning inside an object. You never want the view to look very cluttered or to kind of confuse the viewer to see if there's anything going on inside the object. You don't want to block it with one of your dimensions. So you always want to show it on the outside. Extension lines can cross object lines, which are, the actual things defining the object, and other extension lines, like you see over here, but they cannot cross one of the dimension lines. Otherwise, it's very confusing. So that's a way to check whether things are nested properly. For something like a hole, anytime you see a circle is marked by this symbol. This is like a phi, like a diameter. Whereas an arc is marked by an R for radius. So if it's a full circle, you always need a phi somewhere. That's another good thing to check. Now for cylinders and arcs, again, we get to what I just said. Diameter phi of cylindrical features, and holes. Radius for fillets and rounds, those are just these arcs. So radius just still goes to the center line. You don't actually need to show this thing over here. And you just point to it, and all of them need to be at a 45-degree angle that is collinear with the center of the circle, if possible. There are some times where it's not possible to do that, in which case just put it in a location that is clear. And you'll see what I mean when you actually get into the assignment. Okay, so that's about dimensioning. Finishing surfaces, this is less important for civil engineering, but I think the general thing that you're going to want to do is, when you're looking at dimensions, think about what are the minimum amount of dimensions I need to describe this shape entirely to someone else. So if I'm saying, okay, here I have a block, it has a hole in it, they're going to ask you, where is the hole and how big is it? And that's exactly what you're going to be trying to describe with your dimensioning. So if we're going through an example like this one, let's see how this works. First, I want to get the very basic dimensions, like height and width. So I can just take extension lines and extend out. This is my width. And my height is going to be over here. Now, do I want my height to be over here or over here? I want it to be on this side because that means it's dimensioned between two views. So first, I'm going to get the smallest height, this thickness. Followed by an intermediate height, like the height to this feature over here. Followed by the maximum height, this one over here. Notice how I've nested the smaller ones inside of the bigger ones. also, this height can also be used to describe that one. Pretty good, right? What else do I need to show? Well, I have two holes over here that are the same, so I can actually label them just like that. If I draw an arrow to these two holes, I can just label this as 2 by phi. I don't actually know the dimensions here, so for the purposes of this example in the assignment, all you have to do is draw the arrows. I have two holes. Now the next question is, where are they located with respect to what I know? With respect to the bottom edge, let's just draw those two dimensions. I have this dimension for the height of the first one, and this dimension for the height of the second one. How far in are they located? Would I put the dimension down here or up here? I want it to be up because that way it's between two views. Here and here. Then I see a curve here. I know that curve needs to be labeled. The center of this, if it were an arc, if it were a circle, would be something right over here. So I'll just make sure that I draw kind of at a 45-degree angle, it doesn't have to be exact, where this radius is located, r. Now I need to measure something like the width of this rectangle, right? Because I can't see that really anywhere else, and I also wouldn't put it over here because that's not really the most descriptive, which can be argued, but I'm just going to extend these up and draw it over like this. Now note, I am not doing a dimension to this curved feature. I am measuring this rectangular feature. Never dimension to something that is curved. So you know that if you see a dimension that is measuring to like a curved surface, reject it, unless you can see something else underneath. Okay, what else is important on my shape? I can start to do things between these two views. So first of all, I want to locate where this little arc is located and also what it is. So I'm going to first draw this dimension, saying, oh, my arc is over here. And then I also need to label the radius. So I can just label it like this. And over here, and call that r. Okay. I want to mark the thickness on this one and this one. Which one is it more descriptive on? I would say on this front view. So I'll draw the thickness. And then, oops, that other one's a little bit long. I can get this dimension from here to here. This is a little bit more descriptive, so I'm just going to measure it on this face. And then finally, I can get the full length of the object between these two views. And that should be a little bit shorter, so they're not confused. Something like this. Okay, let's see if I have everything. I've got a block. It is this thick. It's got cuts out of it. And it's got this fin. It's got two holes, same diameter, located here, here, here. It's got this width. I think that's everything. So that's an example of how you dimension something. Now for tolerances. Tolerances is basically a plug and chug from the textbook. So tolerances are the range of things that are allowed in like a manufacturing process. For example, something from civil engineering, rebar. Rebar is sized a little bit differently. Each rebar has a number which corresponds to the amount of eighths of an inch that it is in diameter. And of course, you can say that something is a quarter of an inch, but when you make it, it's not going to be perfectly a quarter of an inch every time. That's what tolerances are. Tolerances are the range that results can come in when you make something. So in the textbook, starting on this page. Let's see. Starting on page 358, there's this table that is called ANSI Preferred Whole Basis Metric Clearance Fits Metric Units. So that's for preferred whole basis, and I'll explain what that is in a moment. So right now it says preferred whole for this table. This is completely unrelated to what's up there, by the way. So basic size says 6. I come down to my table to 6. Class of fit is free running. I come over in the table to free running. 6, free running. I see that the limit's on the whole size, 6.030. The minimum is 6.000. Shaft size, limits on shaft size, 5.970 and 5.940. My tolerance on the hole is the difference between the biggest and smallest holes, so that's 0.030. Similarly, on the shaft, it's the difference between the biggest and smallest shaft, 0.030. The allowance is the difference between the smallest hole and the biggest shaft. Coincidentally, that's also 0.030, but it's not always going to be. So remember, difference between here is allowance, difference between these two are tolerances for each one respectively. Now, what does it mean to be preferred whole basis? That means that the minimum size for the whole is equal to the basic size. So it prefers the whole because the whole is more perfect. Similarly, for preferred shaft basis, that means the largest shaft size is equal to the nominal dimension, or the basic size. So just remember that. You can figure out what type of calculation you do based off of what you see the nominal dimensions. Good luck on the sketching assignment. Let me know if you have any questions.